All right, hello everyone, and welcome to our first lesson of Chapter 1 in Pre-IB Chemistry. This chapter is known as the Central Science. Today, your essential question is, how can chemistry help you understand the world? After this lesson, you should be able to conduct systematic observations, use tools to gather, analyze, and interpret data, and describe the function of models in chemistry. Chemistry is the study of matter, which means it helps us understand nearly everything in the physical world around us. What things are made of, what they have in terms of properties, and how they can change into something new. Matter is anything that has mass and takes up space, from the air we breathe to the food we eat to the cells in our body. It is all matter that has mass and takes up space. Chemistry is often called the central science because it connects to so many other areas of science. Understanding chemistry helps us explain concepts in biology, medicine, environmental science, physics, and so many other fields. In other words, because chemistry helps us understand what is happening in the particle level, it then relates to a lot of other sciences. Because all of those other fields of science involve matter and the way that matter changes, understanding chemistry is going to help you understand different areas of science as well. Now, chemistry itself is a huge field, so scientists can specialize in many different branches of chemistry. So the four that I want you to know for this course is organic and inorganic chemistry. So the main difference between those is that organic is going to include chemicals that have carbon, and inorganic chemistry will be matter that does not contain carbon. And the other two branches of chemistry I want you to note are physical chemistry, which is the behavior and changes with energy, and analytical chemistry, which is determining the composition of different chemicals. So chemistry has a huge impact on our everyday lives, even when we don't really realize it. Chemists often work as a part of a larger scientific team to solve real-world problems. And studying chemistry isn't just about learning what happens in a laboratory. It helps us understand how science can be used to improve things like health, technology, and the environment. So this is just a list of different examples of how chemistry benefits our community and our greater society. One of my favorite real-world examples of chemistry is the water filtration system on the International Space Station. So we know that astronauts can't bring up an unlimited supply of fresh water, so water has to be recycled and purified. So this system that they have takes wastewater like their urine, and they use several chemical processes to remove that unwanted substances and deliver back to the astronauts fresh, clean water. So different steps remove those dissolved ions, and they break down different organic compounds with carbon in them and separate the waste products until only water is left, and that water is safe enough to be reused. And I know that sounds strange, taking urine and converting it back into fresh water, but the important idea here is that water is our chemical substance, which we know as H2O. And if we can separate those water molecules from all of those contaminants, then we can purify the water and therefore reuse it. And so that's just an interesting to me way of chemistry being used. So scientific investigations can have different goals. Pure research is done mainly to increase our understanding of how something works, even if there isn't an immediate use for that information. It often begins simply because a scientist is curious and wants to answer a question. Our other type of research is applied. It's designed to solve a specific real-world problem. And with these two types of research, they typically work together. So pure research is going to give us new knowledge, and then applied research can take that knowledge and use it to develop solutions. Let's look at these examples. Ask yourself one question while you're going through each example. Is the goal simply to learn, or are they trying to solve a specific problem? A study assessing whether men or women are more likely to be diagnosed with depression. This would be considered peer research. And that's because the goal is to understand what is happening, not for any purpose in particular. Investigating which treatment approach is the most effective for reducing anxiety means that my problem is anxiety. I'm trying to create a solution to reduce that anxiety, and I'm investigating treatment approaches to try to solve that problem. So this would be applied. Next, it says a study looking at how caffeine consumption impacts the brain. It's not doing it for a desired purpose. It's just doing it to understand how caffeine affects the brain. So this would be an example of peer research. All right, then it says studying different keyboard designs to determine which is the most efficient and ergonomic. Now, the goal here is to create a more efficient and ergonomic keyboard, which means we are collecting this data to then solve our problem of having a keyboard that is not efficient and not ergonomic. So this would be applied. All right, and then we have researching which strategies work best to motivate workers. Now, this one I feel like could be argued either way. So if you want to practice, you could argue it both ways. But I'm going to say that this most likely leans more towards pure because their problem is unmotivated workers. So they're trying to motivate workers, which means they are applying that information to solve that problem. So this would be applied. A scientific theory is a well-supported explanation of why or how something happens, and it's built from a large amount of evidence collected over time. Now, a hypothesis is a testable possible explanation that scientists can then investigate. And then a scientific law describes what happens or predicts what will happen under certain conditions. A simple way to remember the three differences is a law describes what happens, a theory explains why it happens, and a hypothesis leads us to testing an unknown situation or phenomena. Scientific models are tools that help us represent, explain, and predict things that may be difficult to observe directly. A model doesn't have to be a physical object. It can be a picture, a diagram, a graph, an equation, or even a verbal explanation. In chemistry, models are especially important because we often study atoms, molecules, and interactions that are so small that we can't really see them directly. So in that case, they help us visually understand what's happening at that really small level. So chemists use different models because no single model can show us everything about a molecule, because honestly, we don't have all of the technology to perfectly understand it yet. So these three images on the slide all represent the same molecule, which is water, but each emphasizes something different. So on the left, we have something called the space filling model, and that gives us a better idea of the molecule's overall shape and the relative space that is occupied by each atom. However, with this model, it makes bonds really difficult to see. So that's harder when we're learning how many bonds each atom will make to the other, and students have difficulty seeing that in this specific model. In the structural model, which is in the middle, that's going to clearly show which atoms are connected and that the water has two O to H bonds, but it does not realistically represent the size or the three-dimensional shape of that molecule. And then the ball and stick model on the right makes it really easy to see the atoms, the bonds, and the molecular shape. But the atoms are shown too small and the bonds are too long compared to reality. So all of this is to say that models are useful because they can simplify something that's really hard for us to visualize. However, every model is going to have some sort of limitation. So chemists are just going to choose the model that best represents the information that they need. Now let's look at a few important characteristics of matter. So first we have a substance. A substance is matter with a definite uniform composition, meaning it's made up of the same material throughout. So if we have something like table salt, sodium chloride, we know that in a sample of table salt, for every one sodium atom, I have one chlorine atom. And same goes for things like water molecules, right? If we have water, which is H2O, and I'm looking at a sample of water, I know for every one oxygen atom, I'm going to have two hydrogen atoms. Mass is going to tell us how much matter an object contains, and that amount stays the same no matter where the object is located. Weight, on the other hand, depends on gravitational pull. So depending on where you are, let's say Earth or the moon, your weight is going to be different, but your mass is going to be the same. So, for example, if you travel to the moon, your mass would stay exactly the same. So this is my son Beckett. On Earth, he weighs exactly 67 pounds, but on the moon, he weighs 11.2 pounds. But note that his mass of 30.4 kilograms is the same in both locations. Matter can be understood at different scales. So at the macroscopic level, we can see everyday objects like a chair, but if we could zoom in far enough, we could see the particles that make up that matter. So we can organize matter then in elements, and elements themselves are made up of atoms, and atoms are made up of subatomic particles like protons, neutrons, and electrons. So looking at these tiny particles, we can use experiments and scientific models to help us understand the structure and behavior of something so small. All right, so that is the end of lesson 1. Please make sure you can answer these questions before moving on to lesson 2. I hope you have a great day.